presented by officers of Central Government Department. Chairman of this session is Shri S.K. Nirmal Sir, Secretary General, IRC. Co-chairman of the session is Shri Pankaj Agarwal Sir, Chief Engineer, MORTH. Now I request to Shri Ashish Rawat, Assistant Executive Engineer, Regional Officer, MORTH, Gujarat, to greet by bouquet to chair and co-chair of the session. Presentators are Shri H.C. Modi, Chief Engineer and Additional Secretary, R&B Department, Gujarat, and Shri Sandeep Gaur, Superintending Engineer, Regional Officer, MORTH, Gujarat. Shri Zafar Sultani, Regional Officer, Gandhinagar. Dr. I.K. Pateria, Director, NRIDA. Shri Sitesh Kumar Singh, Director, IRCON. I request to Chairman of the session for opening remarks.
Good afternoon. I think we have come to the fag end of the technical sessions. And this is a very important session which we plan every year for all the officers of central government departments, those who are willing to have share their experience. And we want to see that based of the case studies and their experiences they share with all the officers, those who have come here. So this year also we have identified those important projects. In fact, one more project was planned earlier from Ministry, that is Additional Director General of Ministry, Mr. Sarangi also planned to have a presentation on bridge health monitoring. So because he had to go early, so I shifted it to the first day council meeting. Otherwise, it was planned for this particular session. But all these four, I think you will hear the presenters that what are the specialties of these projects which they are doing, or in their organization, what is the success stories and achievements what they have got. And you are free to interact after the end of the presentation, or we can have at the end of all the four presentations then question answer session. So without wasting much time, because already half an hour is lost, so instead of 16:30, now we are starting at 1700 hours. So I will first invite this presentation on Okha Bed Dwarka Signature Bridge, which is a very prestigious flagship project of Ministry of Road Transport and Highways on a national highway. So I will, in fact, I also happen to be Additional Director General and Director General Ministry and supervise this particular project and see the intricacies of this project. So I think it will be very useful for all of you, those who are implementing such large size projects. So Sandeep is our regional officer, and he is involved right from the beginning for last at least 3-4 years in this project. Over to you, Sandeep.
Good afternoon. Am I audible? Today's presentation is about the Bed Dwarka Signature Bridge, which we are constructing in the remote side of Gujarat. There's an island. Actually, Bed is the Gujarati term for island. So it is a bridge connecting Okha mainland to Bed Dwarka island. So we are constructing around a 5-kilometer bridge. It links the Okha on Gujarat mainland to Bed Dwarka. The bridge proper length is around 2320 meters, and we have the highest record-breaking navigational span of 500 meters in this bridge. The cost of this bridge is around 978 CR. As you can see, this bridge connects the mainland to Bet Dwarka Island. And this Bet Dwarka is the home of Lord Krishna. So Bet Dwarka is the Indian version of Atlantis. There used to be a city of gold in Bet Dwarka, which was immersed in sea at the end of Dwapar Yuga. So the main bridge length is around 2.32 kilometers. This bridge also has approach road of around 2.5 kilometers, which is distributed on the two sides. This bridge was, the commencement date of this project is March 2018. Bridge length is 2.32 kilometer. Approach road length is 4.52 kilometers. And the bridge is going to be completed very shortly. The contractor is Messrs. SP Singla Constructions. Design consultant is Vicon Taiwan. Proof consultant is Wenzel. Design consultant is ASC Infra. And proof consultant is Vicon. Authority engineer is RV Associates. The main bridge length, which is the cable stayed portion, is at 900 meters. Span configuration is 200 plus 500 plus 200. The deck width is around 29.6 meters. It's a 4-lane bridge. The carriageway width is 9.5 meters, and it is on pile foundation. In addition to the main bridge, there are approach bridges on both sides. So there are 17 spans on Okha side, 15 spans on Bet side. Deck width is 27.2 meters, and pile foundation is there. The approach road length is around 2.5 kilometers, 1.241 on one side and 1.2 on the other side. And there are two junctions, one on Okha side and another on Bet side. We are providing 3 parkings also, one on Okha side, one on Bet side, and one near the temple, which is called the VVIP parking. There is pedestrian walkway throughout the bridge, around 2.5 kilometer pedestrian walkway is there. There is decorative lighting, and because theme of this project is Lord Krishna, so there is peacock feather engraving on the pylons. This is one of a kind bridge in the world. It has an iconic A-shaped pylon, which is in curve shape. And this pylon is hollow from the inside. There is an outward inclination of around 21 meters from the center. We have used epoxy coated steel in the bridge and M70 grade concrete. And there are 38 cables on each pylon on both sides. So a total of 152 cables are there. And in 80, the cables which are more than 80 meters, they are provided with dampeners. Each strand has been galvanized, enclosed in extruded polythene protective sheath, and bundle of strands are further encased in HDPE tube. The superstructure consists of precast steel segments, which consist of 12 meter, which are of 12 meter size in the main span and 10 meter on the back span. They are pre-assembled and launched through gantry mechanism. The main span has 19 segments on each side. It involves composite construction. RCC pre-class slabs are placed over steel segments, and then stitching is done. The size of foundation for this bridge includes 1.8 diameter piles. For pylon, the depth of piles is 48 meters. For approach span, it is 32 meters. We have deployed jack-up platforms for pile driving. We have used high-capacity rig machines as the strata is rocky seabed. Pile caps, there are gigantic pile caps which involved 1800 cubic meter of concrete, and the concreting had to be done continuously for 3 days. Pile caps of approach bridge are cast underwater. This is also a prominent feature of this bridge, and sacrificial precast shells were used for this. The superstructure of the main bridge consists of the approach bridge consists of spine and wing arrangement. The spines have been launched using a spine launcher of 800 metric ton, which was positioned over the pier caps. Wings have been connected to spine using pre-stressing, and substructure consists of circular piers of 2.6 meter dia. So this project is going to have pedestrian walkways with solar roof around 2.5 meter wide, and all along the pathway there are intricate carvings on the life of Lord Krishna and the shlokas from Bhagavad Gita. The roof is having solar panels, and which will generate around 1 MW of the solar energy. The solar panels, they also have sprinkler system, keeping in view the environment of that area. This is the main parking on Bait side. It is of around 17,000 square meters, and there is a small VVIP parking of 1,400 square meters. On Oka side, we have a bigger parking of around 24,000 square meters. There are 12 number of viewing galleries in this project, and peacock feather engravings and paintings are there on the pylons. And one special feature is the decorative lighting, which will be based on the theme of color of peacock feathers. This was a very challenging project because it is affected by tidal variation. The wind speed is very high in this region. The marine conditions, there are a lot of problems because of the marine conditions, and there are a number of adverse weather conditions because this is on sea coast. Lot of cyclones have affected this project. The most recent one was Biparjoy in 23. In 2021 it was Toti, and in 2019 there were 2 cyclones, Vayu and Maha. COVID-19 pandemic also affected this project. This project is going to be launched very shortly, inaugurated very shortly. The progress is nearing to 97%. And this will ensure seamless connectivity between Oka and Bait Dwarka. Earlier the people had to depend on the ferries which ply between the mainland and Bait Dwarka. But after that, because of the ferry service is affected by weather. But once this bridge is commissioned, then after that, the life of the local residents will be transformed entirely. This is a projection of the pedestrian walkways. There will be provision of music based on the bhajans of Lord Krishna and the teachings from the life of Lord Krishna. There are engravings of the shlokas from Bhagavad Gita. This is how the bridge will look like. This is the view of viewing gallery at the pylon location. On each pylon there are 2 viewing galleries. This is the pathway to the temple. This is how the peacock engraving will look like. We also have a short video of the This is a video of the actual bridge. To put things into perspective, I would just like to tell that around 1,50,000 cubic meters of concrete was used in this project, around 50,000 metric ton of rebars, around 10,000 metric ton of structural steel, and around 1,500 metric ton of stay cables. So I welcome you all to visit this bridge once it is open to traffic in January. Thank you.
Thank you, Sandeep, for giving a glimpses of the bridge under construction. And though the original schedule has been delayed because of the challenges you have seen already, that tidal waves, then it is inside sea, they are constructing this bridge, so, and even COVID, so there were a lot of issues. But finally, it's going to be completed very soon. 97% progress is already there. So we will have the question answer after the end of all the other remaining 3 presentations. So the next one is experience of success story of NHAI by Sri Zafar Sultani, who is a regional officer of Gandhinagar, based in Gujarat, for Gujarat. Please.
Good evening to all, respected chair, co-chair, my co-presenter and other participants. Actually, time ka slot is a very small slot, so it is not possible to express all my views and all works done by NHAI in the Gujarat. But I will go fast and explain things, some challenges we have faced, and two world records we had built in construction of PQC and also bituminous concrete. So I am starting now with the permission of chair. Gujarat, in the state of Gujarat, total length of national highway is 7,400 kilometers, out of which 4,000 are being built by National Highway Authority of India. Detail of this is the completed project detail, how much PCC issued, how much projects under implementation you can see on the presentation board. Balance to award, this is 817 kilometer. There are separate corridors, Delhi-Vadodara 8-lane express mein, under Bharatmala Pariyojana. It is having a length of about 148 kilometer with financial implication of 8,500 crore. There are five projects, out of which 77 kilometer has been built up. Overall physical progress is 63%. Out of these 5, 1 package has been completed. Next section is Vadodara-Mumbai section, where there are 10 projects, 275 kilometer length, having financial cost of overall 18,000 kilometer, out of which 106 kilometer has been completed. Overall physical progress is about 65%. Another sector is Ahmedabad-Dholera Express Highway. This consists of 4 packages, total length 109 kilometer, about financial cost 5,000 crore. इसमें हमने एक म्यूनिसिपल वेस्ट का यूटिलाइजेशन किया है. We have utilized about 12 lakh tons of municipal waste utilized in the construction of embankment of Ahmedabad-Dholera section. Another section is Sanchor-Santhalpur Express Highway, which is having 4 projects, 125 kilometer, and it is about 94% complete. Another coastal highway, there are 6 packages, 256 kilometer with financial implication of 4,000 crore, out of which we have completed 223 kilometer. Overall progress is about 88 kilometer. Soon it will be completed. Another projects which are under implementation by the NHAI listed in the table. Now I go ahead. Status of upcoming project, about new projects we are going to take up about 800 kilometer, having financial composition of 24,000 crore. Now I will share with you some success story of regional office Gujarat. We have built 2 world records. World record created in the state of Gujarat by MORTH, NHAI. Construction of 2.5 kilometer long, 2.5 kilometer long, 4-lane cement concrete road in 24 hours. Another is highest quantity of bituminous mix laid by the road construction in 100 hours. This is in Panchmahal district. Some salient feature of this are as below. These are the project detail. Concreting of highest PQC, highest quantity of pavement, quality control laid in 25 hours. We had set targeted of 12,000 cubic meter and achieved 14,000 cubic meter. Largest quantum of pavement quality concrete production in 24 hours. This is also about 12,000 cubic meter, or we have achieved 14,000. Laying 1,200 meter we had decided, but we have achieved 1,285 meters. Total area covered at 48,000 square meter. These are the machinery utilization. These are the utilization of resources. This list of the instrument and manpower resources utilized. This is the list. Cross section is also there in the slides. This some of the photographs of the world record. ये bird eye view of the plants है. This is the construction site. This also is another plant site. These are the certificate issued by these agencies, India Book of Records and Golden Book of Records. Next is DBM laying 42,000 metric ton in 50 kilometer lane width within 100 hours. This is the machinery utilized in the creating this world record. Cross section is also illustrated. This world record, some photographs are there. These are the certification given by the agencies. India Book of Records, longest length of the flexible pavement, DBM course, road construction in 100 hours. This is the highest quantity of bituminous mix laid for road construction in 100 hours. In this project, Delhi-Mumbai Express Highway, we have also utilized some new technologies. I will share with you some of them. These are the precast boxes, 2 by 2 meter sizes and 3 by 3 meter sizes. Pakona plant was used, and they were constructed at plant site, transported and fixed then. Some shoulder drains are there with wayside amenities. We have also constructed wayside amenity because it is controlled express highway. There are 3 types of wayside amenities. Type 1 is for passenger facilities. Type 2 is for truckers, good vehicles. Type 3 is both passenger and truckers. These are the facility available which are there in the wayside amenities. This is the bird eye view of this wayside amenity between Vadodara and Mumbai in the state of Gujarat. Some photographs are there. This is animations. After complete construction, it will look like it. There are dhabas, motels, food courts, trauma centers also there. Fuel station is also there. dormitories for drivers. Now I will show some slides, some videos. पहला कौन सा दिखा रहा है? ये साइड का? ये गुजरात this is the small presentation, small video showing the progress of the highways in Gujarat state.
इसके द्वारा लोगों के और माल की दक्ष एवं त्वरित गतिशीलता से आर्थिक उन्नति के अवसर बढ़ते हैं और देश को विकास की ऊंचाइयों को छूने में मदद मिलती है। भारत की मौजूदा सरकार ने परिवहन की महत्ता को पहचानकर त्वरित कदम उठाए हैं और विश्व की अग्रणी अर्थव्यवस्थाओं से मुकाबला करने के लिए देश में कई महत्वपूर्ण विकास परियोजनाओं का निर्माण किया है। इसी दिशा में दिल्ली मुंबई को आपस में जोड़ते हुए और देश की जीवन रेखा के समान 1350 किलोमीटर लंबा और 8 लेन वाला दिल्ली मुंबई एक्सप्रेसवे भारत की अर्थव्यवस्था को अभूतपूर्व बुलंदियों तक ले जाने के लिए तैयार हो रहा है। भारत का ये सबसे बड़ा एक्सप्रेसवे दिल्ली, हरियाणा, राजस्थान, मध्य प्रदेश और गुजरात से होता हुआ महाराष्ट्र से जुड़ेगा। इसमें गुजरात राज्य से गुजरने वाले हाईवे की लंबाई 425 किलोमीटर है, जो कि करीब 28,000 करोड़ रुपए की लागत से परिपूर्ण किया जाएगा। गुजरात की भौगोलिक और प्राकृतिक परिस्थितियों को ध्यान में रखते हुए भारतीय राष्ट्रीय राजमार्ग प्राधिकरण के द्वारा दाहोद, पंचमहल, वडोदरा, भरूच, सूरत और वलसाड से गुजरने वाले एक्सप्रेसवे के इस योजना के निर्माण का काम 16 हिस्सों में बांटा गया है। इनमें दाहोद से वडोदरा तक जाने वाले 6 हिस्सों में सड़क चिरस्थायी बिटुमिन पेवमेंट की होगी और वे ईपीसी यानी इंजीनियरिंग, प्रोक्योरमेंट और कंस्ट्रक्शन मोड के तहत बनाई जाएंगी और वडोदरा से वलसाड तक जाने वाले शेष 10 हिस्से HAM यानी हाइब्रिड एन्युटी मोड के तहत बनाए जाएंगे, जहां सड़क कंक्रीट की होगी। राष्ट्रीय राजमार्ग प्राधिकरण द्वारा इस अत्याधुनिक एक्सप्रेसवे में उच्चतम गुणवत्ता वाली निर्माण सामग्री का प्रयोग किया जा रहा है, ताकि भारी यातायात के बावजूद सड़कें कम रखरखाव के साथ लंबे समय तक सुरक्षित रहें। 310 अंडरपास बनाए जाएंगे, जिससे स्थानीय निवासियों को एक्सप्रेसवे पार करने में सुविधा रहेगी। एक्सप्रेसवे के यात्रियों के लिए नियमित दूरी के अंतराल पर आधुनिक यात्री सुविधाओं की व्यवस्थाएं भी प्रदान की जाएंगी। गुजरात भर में त्वरित, कुशल एवं निर्बाध संचरण के लिए एक्सप्रेसवे के अंतर्गत 59 बड़े पुल, 187 छोटे पुल, 17 इंटरचेंज, 17 उड़ान पुल और 8 रेलवे ऊपरगामी पुलों का निर्माण किया जाएगा। यह एक्सप्रेसवे गुजरात के अहमदाबाद, वडोदरा, भरूच, सूरत और वलसाड नगरों को शेष भारत से जोड़ेगा। भरूच में नर्मदा नदी पर बनने वाला एक्स्ट्रा टॉर्च केबल स्टे पुल पर्यटन आकर्षण के साथ साथ यांत्रिक शिल्प की एक मिसाल होगी। इस मार्ग को सुंदर और परिवहन को दर्शनीय बनाने के लिए पूरे एक्सप्रेसवे पर वृक्षावलियों के रूप में करीब 7 लाख पेड़ पौधे लगाए जाएंगे। वर्ष 2020 में आई कोविड-19 की विश्वव्यापी तबाही के बावजूद इस महत्वाकांक्षी परियोजना का काम पूरी गति से चल रहा है और इसे रिकॉर्ड समय में पूरा करने की दिशा में सरकार, प्राइवेट कंपनियां और समस्त भागीदार एकजुट होकर युद्ध स्तर पर काम कर रहे हैं। इस शानदार एक्सप्रेस हाईवे से जुड़ा प्रत्येक सहभागी अपनी प्रतिबद्धता और समर्पण को साक्षी रूप में यह प्रदर्शित करेगा कि भारत प्रगति और विकास के पथ पर अबाध रूप से अग्रसर है। जय हिंद।
दिखा एक बार।
लास्ट वाला ना सर?
वो करो। टाइम ज़रा कम है, पर एक मैं वेस्ट साइड एम्यूनिटी का एक एनिमेशन भी दिखा देता हूँ आपको। शुरू हो गया। Thank you.
Thank you, Mr. Zafar, for showing the success story of NHI, especially wayside amenities and what facilities you are providing and progress of various projects, status of projects. Now we come to the third presentation on progress, achievement, and technology adoption in PMGSY by Dr. Pateria, who is a director in IRD.
Good evening, respected chairperson, co-chair, my fellow presenters, and esteemed audience. I will be presenting before you the achievements of Pradhan Mantri Gram Sadak Yojana, a rural roads scheme started almost 23 years back, and the original scheme is likely to be closed as per the current instructions from Government of India in March 24, as majority of the targets have been already achieved, and whatever is remaining is very minimal. We will be
We are targeting it to be completed by March 24. So I will be taking you quickly through the targets and achievements. The first scheme, I was just referring to PMGSY-1, which was started in 2000 to connect 178,184 habitations. Majority of them have been already connected by construction of almost 6.22 lakh kilometers of roads during last 23 years. PMGSY-2 was started in the year 2013 with a target of 50,000 kilometers of roads, only upgradation part, and almost 48,000 kilometers has been already completed. Remaining is on the verge of completion. The third component of this scheme, RCP LWEA, Road Connectivity Program for Left-Wing Extremism Affected Areas, was started in the year 2016 with a target of 12,000 kilometers, and 8,239 kilometers has been already completed. The last component of it, PMGSY-3, was started in July 2019, and this is the scheme which we will be completing by March 2025. So all three other components are scheduled for completion in March 2024, and the last one is scheduled for completion in March 2025. And under this scheme also, almost in this scheme also, almost 68,000 kilometers has been already completed. This is what we have achieved during last couple of years. A quick presentation of what lengths we have completed during the last couple of years. From this data, you will find that at one point of time, we were constructing roads with an average speed of almost 135 kilometers a day. And now, because we are almost at the fag end of the scheme, so the completion rate has reduced, but still we are working with a speed of almost 45 kilometers per day. Not only that, along with this, we are also implementing the new technologies for which we are constructing the roads with equal speed, almost half of the total completion. That is, if we are constructing 45 kilometers a day, almost 25 kilometers are being constructed with various new technologies. These are the financial releases and expenditure over the years. Various new technologies which are being adopted. In fact, we issued guidelines in 2013, and since then we have started implementation of various new technologies in different states based on the need and based on availability of the materials. These are the new technologies which are being practiced as of now, and till now, 1,43,761 kilometers of roads with various new technologies have been sanctioned, and 94,000 kilometers has been already completed. On right side, you are seeing couple of documents. As engineers sitting over here are well aware that luckily Secretary General IRC is chairing this session. We have a tradition that IRC brings out the guidelines and codes for implementation of various technologies and various other systems. But at the same time, the committees keeps on discussing, and after getting lot of data from the field, they finally approve, and then it goes to the council, and finally it is published. So it takes a lot of time. To avoid that, we started with publishing a lot of documents at our own for the time being, so that the implementation starts immediately. And these are in the form of do-it-yourself booklets. A few of them are being presented over here. This is overall increasing sanctions under new technology, which have been already given to the states. These are the do-it-yourself booklets, which have been already published by NRIDA, so that few of them may be on the subjects for which IRC guidelines have been already published. But looking into the implementation related things, because these roads are being constructed by Jila Parishads and the rural engineering departments in different states. So for ease in understanding, these booklets have been brought out like that on white topping. We already have a IRC guideline, SP-76, but further simplifying the language, the technology, this guideline has been brought out so that people can go through it and start execution or adoption. Then we have a very strong IT backbone for monitoring of the scheme and even for implementation of these new technologies. So this is the website through which the entire PMGSY is being monitored. This is our data website being managed by Center for Development of Advanced Computing, that is CDAC Pune, omms.nic.in. This has live data. Each and every module will have live data updated from the ground level by the engineers at district level. We are also monitoring through regional review meetings, performance review committees, pre-empowered committees, etc., etc. We have a citizen information board for transparency. Monitoring is also being done through independent common review missions and national level monitors. Monitoring by public representatives. This is the ecosystem of ICT initiatives. The MIS is OMAS. Then we have a GIS in the name of GRIS. We have a GeoSadak application for mapping of the various facilities, and large number of facilities which were not on GIS have been brought on, so that all other departments implementing various schemes of Government of India or state governments can make use of it. We have a mobile-based application known as Meri Sadak, through which any citizen can put any suggestion or a complaint onto the website. We are expecting our concerned program implementation unit to revert back in 7 days' time and finally take action on it within 60 days and then close the complaint after it is addressed. We have a strong quality monitoring cell and a monitoring app as well. All monitors are carrying out the inspections and uploading the inspection report through this quality monitoring application. We have a GIS cell within the organization. This is the PMIS progress visualization in Gantt chart for PMGSY 3 alone, because other two schemes are being closed. So all projects of PMGSY 3 are being monitored through this PMIS. This has been developed in-house. We also have eMark, a software for management of maintenance, which is evidence-based digital platform. Performance-based maintenance contracts are being used for maintenance of these rural roads. And huge savings are being achieved with the use of this eMark, as PIOs and contractors can do inspections, generate bills, obtain approvals, and process payments. This system has a marking system. This eMark has a marking system. So the PIO will carry out the inspections, award the marks, and if maintenance is proper, if more than 80% marks are given to any road, then only the payments can be made. So there are a lot of restrictions which have been put in. We have a 3-tier quality monitoring system, and the first tier is at PIU level, second tier is at the state level, and third tier is at the national level. Large number of inspections are being carried out, and all these 3 tiers keep on uploading, 2 tiers, second and third tier keep on uploading their inspection reports and corrective actions wherever required onto the OMAS. These are some new initiatives which have been recently taken to manage the quality. Number of quality monitors has been increased, number of inspections has been increased. Now each and every project quality monitoring register is also available on the website. This is the PMGSY dashboard for overall citizen viewing. monitoring by us and viewing by anyone at the system. These are the detailed dashboards. We are supplying almost 20 layers now. This is an old slide. Now 20 layers have been made available onto GIS, and they are being pushed on to Gati Shakti project. This is PMGSY, National GIS and GeoSadak. Now, rather than talking on to various new technologies which we have adopted and completed huge length, I will be just presenting before you the much expected technology and much talked technology, that is full depth reclamation, in which we are doing stabilization by using cement as well as commercial chemical stabilizers. Most of you must be aware that we do not have the guidelines for implementation of this technology from IRC. So last year, an international conference was organized under PMGSY, and these guidelines prepared through various experts were released to start the projects. So in May 22, these guidelines for full depth reclamation for rehabilitation of low volume roads were released. Another reference which is being used is SP89 for commercial chemical stabilizers. This is what we are trying to do. Subgrade is kept as it is. The existing crust layers, including thin bituminous layers, they are being mixed together through this full depth reclamation, and a combined stabilized base by use of cement and other chemical materials are being prepared. And then finally, with the use of a crack relief layer and bituminous layer is being laid. So the road gets completed. The speed is almost 500 meters a day, right from top of the subgrade. So the speed is very fast, and for our roads are very small in length. Maybe the average length is around 5 kilometers. The longest one may be around 30 kilometers as of now. So road gets completed in a period of say 15 to 20 days, even if it is 30 kilometers long. There are a couple of limitations of this technology, and my request to those who are listening over here is that please have a detailed study of the booklet which is available, because even international literature on full depth technology is very, very limited. So we have tried to collect all the international literature, sum it up with the help of various experts, and brought it into the booklet which is available under publication section of NRIDA, pmgsy.nic.in. All our publications are available free of cost on the website and in citizen domain, so anyone can go to that section, download it, and use it for reading. So without understanding and without knowing the limitations, one should not embark upon the use of this technology, because that may have a lot of complications. Wherever there is a limit, there is an issue of drainage, please have thorough investigations before taking a decision of implementing FDR technology. These are some of the things I have brought in from the SP89, the guidelines for the commercial chemical stabilizers available from IRC. Under this technology, for successful implementation, a very important part is job mix formula preparation. We have advised the states to get the job mix formulas prepared through some technically competent agency, mostly through IIT, NIT, or other government research institutions, because they have all those facilities and can do a rigorous work on preparation of job mix formula. We have also advised to execute initially a trial stretch of 200 to 300 meters with the use of this job mix formula, and test it by taking course at 7 days and 28 days as per the IRC guidelines. Once this trial stretch is found to be satisfactory, proceed ahead. The agency can give a go-ahead for the stabilized base layer. Durability and residual strength results should be verified before giving go-ahead for construction of this FDR layer. This is how the cores are to be taken and they are to be tested. So as of now, SP89 suggests two ways of testing this structural layer of stabilized base. One is through testing of UCS by taking these cores, and the other one is falling weight deflectometer. We are all aware that falling weight deflectometer are having limitations of their availability in the country as of now, and the cost for carrying out this test is also relatively much higher. So we prefer to go through the coring system, getting them tested at regular intervals. These are some of the cores being shown from various sites. These are the failure patterns in those cores. I'm showing a couple of pictures just to make you aware that please carry out the work as per the instructions given in the booklet and without compromising with the basic engineering principles. For example, the height of embankment. For rural roads, we have a specified minimum height of embankment as 600 mm. The IRC says 600 mm should be the bare minimum height of embankment plus subgrade. So there should not be any compromise. I'm just flashing these photographs so that you should be aware that this is not a good way of doing the things. The shoulders and the slopes should also be compacted along with the stabilized layer, rather than focusing only on the stabilized layer and then trying to compact the side slopes. These may be the situations if the work is not carried out as per the specifications. You may not be in a position to get the core for variety of reasons. So please ensure during the trial stretch that you have got the mix design done properly, executing the work through proper compaction by mixing the requisite quantity of cement and the commercial stabilizers, and then getting the cores and testing them. This is another picture which shows that the CD work has not been done, but the stabilized base layer has already been completed. So this is also not a very good practice of executing the works, because basic principle. Now what will happen in this case? The structural layer will get damaged when the CD work is constructed. The second photograph shows that the CD work has been now constructed at a later stage. But then the stabilized layer will get damaged, and for that small stretch, you will have to bring all the machinery once again to the site. So those things needs to be looked into. Cracks developed in trial stretch. Wherever we are using cement, in a stabilized basis, there are always chances of development of cracks. If these cracks are surface cracks, nothing serious, not to worry. But if they are increasing in depth with passage of time, your pavements are likely to behave adversely. So we have to be very, very careful. And the important thing is neither a higher dose will serve the purpose nor a lower dose will serve the purpose. The strength specified in SP 89 is between 4.5 MPa to 7 MPa. So it is very difficult to have this strength in a very narrow range. And for that, repeated trials of job mix design are extremely important. If we go with repeated trials and carry out the work in a systematic fashion, nothing to worry. So cracks like this, if they remain on the surface, even after passage of say 28 days or so, nothing to worry. Another important precaution is immediately after you take the course, get it tested after 28 days. Please do not leave it for months together like this. The tack coat should be laid, and then sami layer or whatever we are doing, that should be laid, and finally bituminous layer finishing should be done. This is another photograph of a poorly executed work in one of the area. So brought just to make you aware that this should not be. And this is again the same photograph indicating that the adjoining land and the top of the road are almost at the same level. So that kind of mistake should not be there. And this is the citizen monitoring app known as Meri Sadak, through which the complaints and suggestions can be put on by the citizens, and you will get the revert within 7 days' time. Thank you very much for giving this opportunity.
Thank you, Dr. Pateria, for a very informative presentation on PMGSY and various issues involved and challenges and success story. Now we come to the last presentation, that is the experience of success story of IRCO and IRCON by Sri Sitesh Kumar Singh, Director IRCON. Please.
Respected Chairman, sir, Co-Chairman, sir, fellow presenters, esteemed delegates, colleagues, and logistic friends. Though IRCON International is executing so many projects, but I have, because of the limitation in time, I will be discussing only one project where we have done some innovative techniques used for a dedicated freight corridor corporation of India Limited, that is the high-speed goods train line. So some of the innovative techniques we have used, so I want to discuss it. So it is in the Sachin-Vaitarna section of Mumbai division of Western Railway. So I have divided my presentation into 3 parts, a very brief about the project, and then the techniques. Techniques are some of the civil engineering techniques and only 2 techniques from the track side, PBA side, because being highway engineers here, so I want to go for the track part. And finally, the takeaway. So this project is total, this project it runs parallel to the Mumbai-Delhi Rajdhani route, starting from Vaitarna, which is a suburb of Mumbai near Virar, and up to Sachin, that is 15 kilometers short of Surat. So it is total 186 route kilometers, out of which it is double line. So total 372 kilometer main line, 5 crossing stations, and then some depots, sidings, connection with the Indian Railway system. So 60% of the project falls in the state of Gujarat and remaining 40% in Maharashtra. So this is a design build contract and awarded to a consortium comprising of Mitsui, a Japanese company as the lead partner, IRCON International Limited, and then Tata Projects Limited. There are 3 packages were allotted. Only one package, that is CTP-12, that is civil and track package, is being executed by IRCON International exclusively. So original cost was over 2,700 crores, and now it has gone up to 3,400 crores due to some variations. So the quantum of work has been indicated here, like 155 lakh cubic meter, etc., of earthwork, etc. The various, now I'm coming back to the innovative techniques for civil engineering part which we have used, is the introduction to the stilt bridges. Then we have used a special crown for reaction pile load test. Then introduction of RCC twin box segments as opening through one of the ROV approaches. Then gap filling with soil wrapping with geogrid and geotextile. Then we have constructed one largest RCC rotary slab for junction of a ROV, 4-leg junction of an ROV. And then provision of prefabricated vertical drains for ground improvement work. And then RCC U-girder, we have introduced RCC U-girder as substructure for ROVs. And the last thing of this presentation will be provision of precast segments for drain ducts and the box culverts. So I will discuss briefly one by one. So out of the entire 186 route kilometers, 5-kilometer route is very near to the coastal region of Palghar district of Maharashtra, near Arabian Sea. And the challenge, the normal formation initially planned was with the normal earthwork. But because of the challenges there were 3 challenges. The first was, in the 24-hour circle, twice tide comes and leaves, inflow, outflow, and the water remains stagnant there for 4 to 5 hours. It is a low-lying area, so normal formation was not possible with this system. Secondly, there are thick mangroves. So forest department did not agree to allow for the large-scale cutting of mangroves. And third thing, the top two layer of the existing soil is totally black cotton soil, slushy, muddy, marshy, etc. And it is not possible to go for any type of formation, even with ground improvement in some of the patches. So wherever the tide was predominant, we went for the construction of stilt bridges. Stilt bridges are nothing but pile cap and pier cap is common. I mean the superstructure rests directly over the pile cap. So in 3 patches where the tide was predominant, we went for the stilt bridges. And of course, we had the same superstructure size for all the, same span for all the, this thing, 70 span, 70 up, 70 down. So 140 total deck slabs, each deck slab supported over 2 eye girders. So total 280 eye girders and all. So all the piles used in this stilt bridges mostly were of 2-meter dia. So we needed a test load of 4,500 metric ton for initial pile load test. We checked that no crown of this much capacity was available in India, so we searched overseas also. Then we found that Taiwanese had used 4,000 capacity crown. So we requested them to provide the design, so they agreed to provide some 30% extra reserve strength with us. So 6,000 metric ton crown design was given by Taiwanese. We checked it from our own office by Stoop and finally corporate office consultant. And we successfully conducted this test. This we did for the first time in Asia. Okay. So now another interesting thing we did was regarding the introduction of twin boss RCC segments. For mechanized track laying, it has to be a continuity of the formation. So on the parallel to railway side, one ROV was there, Valsad ROV, where we had the infringements of the pier approach. So the new ROV was, though it was sanctioned, but being a long lead item, that track laying machine was already coming from the Surat side to Mumbai. So we wanted to have opening through one of the approaches of the Valsad ROV. So then we went for the precast segments, twin box segments, so that one up and down track pass separately. The size was because of the double-decker container has to go in the dedicated freight corridor instead of the single container what we are seeing in the normal railway track. So the size of the box is important, 16 meter by 10 meter and 1 meter segment. So we had 20 such segments along with the base slabs, 14 base slabs, 34 segments, and we started this work at the end of April 2021, and it was a peak COVID time, so second wave, so it was a very challenging time. All the oxygen cylinder, etc. was disallowed, so we had to, but in spite of all the hardships, we completed this work, and we took the block 20 days, only road block 20 days, from 2nd June to 21st June, and we completed the entire job in time. So it was well appreciated by all corners, even for transporting the 16 meter by 10 meter, 90 ton panel, segments. We especially designed the steel frame over the trailers, and we got this by wide media coverage, etc. And it was recorded in the India Book of Records as well as in the Limca Book of Records. Then placement of segment was one part, and filling the backfill was another challenge. So within 20 days we had to do this. Construction of retaining wall was not possible. Secondly, if you go by the Gabion wall, it was not possible because of the restricted space. So we went for some new technology, that is the geo-wrapping with geogrid. So it is just L-shaped reinforcement cage. We took help from the IIT Mumbai also. So this is L-shaped reinforcement cage. So size is the 600 millimeter by 800 millimeter. It is in parts, and then geogrid is put inside this, and then geotextile, and it is filled with the crushed stone aggregate. So with duly rolled. So it is, you can visualize in the crude way like it is a gunny bag filled with the crushed aggregate, duly compacted. So this is the method we did it. And having successfully done this job, we also use this technology for making abutment for our service girder, because at one of the road under bridges near Pardi station, LC 89, we had to do the box pushing in the Indian Railway track. At the same time, we had to allow the mechanized track laying track also. So service girder were to be placed. So we use this same material as abutment for the service girder. And because of the very less space it consumes instead of our conventional CC creeps, etc. Now another thing, one largest rotary we also constructed in ROB. So its area is 1600 square meters, along with the 1.5 meter deep and some 2000 cubic meter concrete, etc. Because of the quantum of work involved, it was recorded in the Asia Book of Records. Another, in the same coastal regulatory zone, as I have told, apart from the steel bridges, the remaining portion where tidal waves are not predominant, we went for the prefabricated vertical drains. This is a very good thing, because if you see at the bottom, I don't have the pointer, so I can't show. Lower portion is the soft clay, and in the clay, we have to take half a meter of earth and replace with the good earth so that our masonry can come, because it was totally dal type ki cheez thi. So we had to replace it, and 150 mm has to be with 8 to 10 mm aggregate as a drainage layer. And then driving is done for the prefabricated vertical drain, which I will show later on in the photograph. And after driving, you have to place the next 150 mm, 10 to 20 mm aggregate, and it is at the slope so that water can drain out through this permeable layer. And over this, we place one layer of geotextile, and over the geotextile, you have the entire earthwork formation. So that earthwork formation itself gives the preloading part, and through this vertical drains, it acts on the capillary action, and water rises up due to that loading, and ultimately it goes out from the sides. So it is a long time consolidation process, and for instrumentation, we have to provide the settlement plate at every 250 millimeter and piezometers for pore water pressure at every 500 meter. So this is a geotextile, a prefabricated vertical drainage, a collapsible circular pipe sort of thing, flexible. So outside is geotextile, inside you have a PVC material corrugated for capillary action. That the next figure shows the that roll, and at the extreme right you can see the excavator, and its arm is a shaft with winch and hydraulic system. At the bottom we have a mandrel, and through the mandrel it drives the PVD into the ground, and through the calibrated part you can see how much it has gone inside the down. That has to be noted down. And if you see the bottom left photograph, so that is the second layer is laid over this, and center photograph shows the geotextile laid over this. Over this you make the formation. Another thing, at one of the dedicated field, our own this DFC formation had two encumbrance of existing ROBs, Safale and Palgar ROBs. Their pier and abutment were coming in the alignment of the proposed DFC track. So the old ROB was to be dismantled by replacing with the new ROB. So replacement was not a problem, but the thing is the headway. For running of the double-decker track and single container freight, the headway difference is 2 meters. So for double container, you have to have 2 meter more headway. So we had to raise the overall road level of the new ROB by 2 meters. But there was constraint and obligatory point on one end. There was a 4-road junction rotary in both the ROBs. So that junction rotary needed to be shifted to maintain that 1 in 30, even 1 in 30 grade. So that was not possible because shifting of that junction was not possible. So what we decided to reduce the overall depth of the gutter. So the conventional gutter of composite gutter is 2.8 meter, 3.3 deck slab on 2.5 RDSO standard. So 2.8 we wanted to reduce it to 0.8 meter. So we went for this PSC U gutter. So PSC U gutter, even the web also is a structural member with pre-stressing. We did it, our in-house design, etc. And successfully done, we have completed this work, including load testing, etc. Another, this precast RCC drains, utility duct segments, etc. Now it is being used everywhere. We have used widely. But the last part, only the box culvert part, I will like to highlight. Already in highway, it has been shown right now. So there were 3 canal crossing. We had to dismantle the old one and replace it for our DFC track. So the Canal Authority did not allow for allowing canal block for more than 2 weeks, 15 days. So we went for this precast segments from Fuji Silvertech. But before using this, we tested the water tightness in their factory, and once we got satisfied, we have used it running now perfectly well. Within 15 days, we did the job, entire job within 15 days by taking block. And now only 2 portions of the track part. One is GPS-based geometrics, this track geometry survey instrument, and secondly, under slipper pad and under slipper mat. Now, GPS-based track geometry survey instrument, normally for railway track, this is for the railway track, it can be used anywhere. The best part is, this is a Trimble make from USA. The best part is that the track parameters are recorded on the, one is the prism trolley in front, and at the rear you can see the, in the front you can see the total station, at the back you can see the prism trolley. So total station and prism trolley, so the entire thing is recorded without any manual intervention. It is robotically controlled and laser guided, and no manual intervention, we only have to move the things. And it kinematically records 2.5 kilometer per hour. So the whatever data it records in 3D, now the GPS coordinates is compares the track parameter with the GPS coordinates, design GPS coordinates, and whatever is the difference in the slew or rail top level can be directly fed into our tamping machines. You take out the pen drive and just feed, because the format is the same. So you feed into the tamping machines and go ahead. So there is hardly any idling for the tamping machine or its operator, etc. It's a very good thing. And the last thing for today's presentation, already time is up now, 1 minute, sir. Under sleeper pad, at one of the location near Boisar, below Boisar ROB in Maharashtra, we had a problem that one pipeline, 1 meter dia, MIDC, Maharashtra Industrial Development Corporation pipeline was going underneath. So after having the minimum overhead clearance and the track, the stipulated 350 millimeter ballast cushion we are not able to provide. Either reduce the overhead clearance below minimum or the ballast cushion. In both the cases, permanent speed restriction would have been imposed. So we searched for some other solution. Then we came to another one, Jetner India, an Austrian firm. They have a branch in Pune, Jetner India Private Limited. We approached them. They have got the vibration solutions. So we approached them. This was done for the first time in India. So they gave the solution, designed the entire thing, that at the sleeper bottom, they had one under sleeper pad. So they have got some polymer mesh. It impregnates with the concrete at the bottom, and at the bottom we provided the sleeper mat, under ballast mat, and the ballast cushion was reduced to 250 millimeter instead of 350 millimeter. So the cost for lowering the pipeline was 8 crores, and timeline was, they had not given the timeline, maybe 1 year, but we did it in 1 month and 3.5 lakhs only. Thank you. So with that being a design build contract, we had so many flexibility to use new techniques, etc., and it saved a lot, cost effective, everything it saved. And with this, I conclude my presentation. Thank you so much.
Thank you for a nice presentation on IRCON success story. Now the floor is open for question answer. Yes, please. You can identify yourself and then you can point out whom you want to have your question. Then you can question.
Yes, sir. My question is for Jafar, sir. Sir, you have told about the success story of NHAI, RO, Gandhinagar, okay? So I think in that one pending project is there. You might know about Ankleshwar-Burhanpur National Highway. You might be aware of that. That highway is split up into 2 parts, okay? So in the Gujarat border, it is under the NHAI RO, which is now shifted to PIU. So what is the status of that? May I know about, because you have told about the upcoming projects also and ongoing projects also. That is my question.
I believe you are asking about Ankleshwar onwards highway.
Ankleshwar to Burhanpur via Shahada, Shirpur. That is originally state highway number 4, which is now converted into NH.
I believe this is not with us. This is not with us. It is not with NHI. It has not yet been entrusted to NHI. NHI only takes up the improvement and development works on the highways, which are entrusted by way of the notification to NHI. So it is not in our.
Sandeep, is it with
No, as per I have the letter, it has been handed over to PIU Bharuch, NHAI section.
PIU, but there is no PIU Bharuch as on date. It has been merged into PIU Surat, and I will find out if it comes to me in my knowledge. I will definitely share it with you.
I have written a note.
Please give your number to my colleague, Mr. Swami, so we can interact later on.
Okay, sir. Thank you very much.
Okay. Yes, please.
Congratulations to these hard-working engineers. You are the pioneers of these structures. As indicated by our respected chair in his opening remarks, the bridge linking from mainland Gujarat to one of the important heritage site related to Lord Krishna has encountered various types of occupational health and safety issues. Would you please love to share one of the incidences which was very disastrous in nature and you took some innovative measures to address it? It will be a very good learning for all of us for the future endeavor in such infrastructure development projects. Thank you.
We have not encountered any hazardous conditions over there, but there was problem of underwater cable was there, which provided electricity to the Bet Dwarka island. So it was disconnected at a number of times. So that was an issue. Other than that, any hazardous situation was not there. Only the working conditions, high speed conditions are there, which restrict the working time. Like there is a specific time of the day when we can do the operations, we can do the survey work. So that way it was challenging, but there's no such hazardous condition as such in that environment.
My question is to Gaur sir. I'm happy to see that signature bridge is in a very advanced stage and 98% work is completed. But as you know, Dwarka is flooded, I will say, over-flooded with pilgrims in the festival of Janmashtami and Diwali. Thousands of cars and hundreds of buses you may see during that particular festival. Did Morth think about how to control the traffic on this signature bridge during this festival season? I have seen witness in my US visit that such kind of signature bridges and cable bridges in US, traffic is allowed in a streamlined manner with enforcing by law. Even on our Worli Bandra sea link, in the peak hours, they are controlling the traffic.
Yeah, that has been accounted for in the design. So during the peak seasons or the festival time, only once the parking in Bet Dwarka is full, after that only pedestrian movement and movement through golf cart will be allowed on the bridge. And that is the way we will regulate the traffic on that bridge.
Okay, that was my session. Thank you.
My question is also related to Bet Dwarka signature bridge. My concern is, could you please throw some light on the difficulties that you might have faced while doing the foundation work of the pylons? Because that pylon foundation is very disaster prone. Recently we had disaster also somewhere in Bihar. So it's a disaster prone. So quality of the piles and those things are very important. Anytime you faced any difficulty and you had to adopt some innovative techniques to solve this problem?
No,
because
we are fortunate to have a very good contractor, and we've encountered rock strata over there.
See, so same contractor was there in Bihar. We had a failure of pylon. I have seen it recently. Same contractor. Or it's navigation. There also navigational span only that it collapsed. Here also we have got longest navigational span, 500 meters. It's very disaster prone. So while doing the work, could you please tell me about how you manage the quality of the piles and all that, pilot tests and any innovative techniques that you adopted to ensure the quality of especially the pylon foundation?
Actually, see, our Gujarat has got a very dedicated design cell, and they have been doing the supervision of the project initially. and after that we have authority engineers, so they are taking care of the quality issues, all the quality issues.
I'm not talking of design issues, I'm talking of the construction issues. If you have faced any while the construction work of pylon foundation was on, that time any special problem that you faced? In depth of water, lot of depth of water?
Actually, we face lot of problem because of the intricate design of the pylon. Because it is the first time that a curved pylon, which is having 21-meter deviation from the center, is being built.
Yeah, yeah.
And it has got a A-shaped pylon. So because of the shape, there were a lot of difficulties. And that is why the pace of progress was also a little bit slow initially. But once it picked up, then there was no such issues. We were able to complete the project.
So while the construction, could you had any type of test on the piles that you had for those pylon?
All the prescribed tests have been done on the piles.
Okay.
My question is to Dr. Pateria, sir. Sir, as you know, I have been associated with PMGSY for the last 4 or 5 years in Jammu. One typical problem we face whenever our projects are vetted, mostly that geology of area and mostly there are hilly areas, is like that is slide prone. So they allow us very less length of pakka drains. They tell we get about 150 meters per kilometer or 200 meters per kilometer, that too in built up areas. But I have seen over a period of time that it becomes very difficult to maintain those drains, and consequently the road surfaces get damaged, because whenever we have to maintain, now we don't have gangs which will work with their hands. We have JCBs, and JCB operator will invariably not do a work unless until he has well-defined edges. Well-defined edges would be only provided if we have pakka drain. And it becomes very ticklish, and then gradually that contractor